Intel will take the road of system-level foundry, will provide silicon, packaging, software and chips, etc. In March last year, Intel CEO Pat Kissinger announced the IDM 2.0 strategy, in which Intel opens its own foundry services to the outside world while expanding the use of third-party foundry capacity, at the Intel on Technology Innovation Summit held in September this year. Pat Kissinger introduced that Intel's foundry service will usher in the era of system-level foundry, which is different from the traditional foundry model that only supplies wafers to customers. Intel provides silicon, packaging, software and die. This is actually a reflection of Intel's efforts to open up its own foundry services. So why did Intel begin to pay attention to foundry services? System-level foundry. If I had to describe Intel's system-level foundry in one sentence, it would be, everything related to chip manufacturing is given. Specifically, Intel's system-level foundry includes four aspects: wafer manufacturing, packaging, chips, and software. Wafer fabrication provides customers with innovations in its process technologies such as ribbon FET transistors and power via power delivery technology. Packaging provide customers with advanced packaging technologies such as EMIB and Foveros. Die, Intel's packaging technology and the open specification for Universal Die High-Speed Interconnect, UCIe, will help dies from different suppliers or produced with different process technologies to work better together. Software. Intel's open-source software tools, including OpenVINO and OneAPI, accelerate product delivery and enable customers to test solutions before production. Decoupling of chip design and manufacturing. Intel's Open Foundry service is actually quite understandable, so it can make more money. It's like rent out your own vacant house so you can increase your income. But if it's just to sell idle chip capacity, there's no need to pay so much attention. The logic behind this is that Intel wants to decouple its own chip design and manufacturing. Friends familiar with the semiconductor industry may know that companies in the current semiconductor industry can be roughly divided into three types: IDM, both design and manufacture, such as Intel; Samsung, fabless, just design and not manufacture, such as AMD, Nvidia; fab, just manufacturing, like TSMC. Although Samsung and Intel are both IDM manufacturers, the situation is not the same for the two. Samsung's chip design and manufacturing departments are relatively independent. For example, many chip products of Nvidia and Qualcomm are manufactured by Samsung, and Intel's chip design and manufacturing departments have long been highly bound. In short, Intel design chips, main products, made by Intel. This creates a problem. That is, the entire design and production is an internal process. That is to say, due to the differences in the process, it is very difficult for Intel to find other foundries to manufacture chips designed according to the internal process. For other fabless designed chips to be manufactured by Intel, it also takes time to adapt to Intel's internal process, which is also more difficult. For Samsung and TSMC, this aspect is not a big problem. Take Nvidia's graphics card products as an example. The chip used by the RTX 3090 is made by Samsung's 8nm process, while the chip used by the RTX 4090 is made by TSMC's 4nm process. Due to the openness of Samsung and TSMC in foundry services, fabless manufacturers like Nvidia can jump left and right and choose foundries relatively freely. Another problem brought about by the high degree of binding between the chip design and manufacturing departments is the low flexibility of production capacity regulation. Chip manufacturers, like most traditional factories, lose money as long as the production machines stop. For this reason, chip manufacturers often need to try their best to fill their capacity. The result of high binding is that the production capacity can only be filled with its own chip products. In this way, when the market environment changes, it cannot flexibly adjust the output of its own chip products. So now Intel is opening more foundry services to decouple chip design and manufacturing, and break the highly tied relationship between chip design and manufacturing. At the same time, establish a chip foundry ecosystem of its own. Final summary: 1. Intel has done chip foundry for other manufacturers in the past, but its presence is relatively low, small number and low market share. For example, the Spreadtrum SC9861G IA is manufactured on Intel's 14nm LP process. 2. Due to Intel's lack of experience in the foundry industry, it may take some time to adjust. 3. Intel is very sincere in opening up EMIB 2.5D package and Foveros 3D package. 4. Ribbon FET transistors and power via power supply technology are the key technologies of Intel's 20A process, which shows that Intel does not want to keep its most high-end technology and will fully open it up. 5. Due to the opening of chiplet technology and some related IP, for some small-scale chip manufacturers, it will be easier to use this technology to design chips. 6. Intel's process characteristics are different from those of Samsung and TSMC, even if it is the same technology node, so for chip design companies, this is an additional choice. 7. Intel's process should be able to attract some server chip manufacturers, such as Amazon.